I would like to welcome you to webinar 2, which is going to be essential oils and the science behind them. This webinar is going to be longer than webinar 1 was because there's a lot of material to go through, but hopefully you will find it interesting. Disclaimer: I'm not a medical doctor. Please consult your physician or pharmacist before using essential oils if you're on medication. And this is just an overview of what I'm going to go over today. What are essential oils made of? Made from? Essential oils in the body, essential oils in the brain. What are essential oils made of? Essential oils are made of two components: hydrocarbons and oxygenated compounds. They're mainly made up of hydrocarbons, and these specific hydrocarbons are called terpenes. And the three different types of terpenes that are in essential oils are monoterpenes, sesquiterpenes, and diterpenes. The second component that make up essential oils are oxygenated compounds, and these include esters, aldehydes, ketones, alcohols, phenols, and oxides. Hydrocarbons, for those of you that aren't familiar with chemistry, just are carbon and hydrogen atoms bonded together. Oxygenated compounds are compounds that at least have one oxygen atom. This is the first type of hydrocarbon that essential oils are made from, monoterpenes. These are some of the benefits of monoterpenes. They stop the buildup of toxins, help eliminate toxins from the liver and kidneys. They're antifungal, antiviral, and antiseptic. And this picture is an example of a monoterpene that is found in an essential oil. And on this slide, I have some of the essential oils, some of the more common essential oils, and what monoterpene are found in those essential oils. So the four that are on there are grapefruit, lemon, lime, and frankincense. And across in the other column are the monoterpenes and the amount that is found in the essential oil. So for example, for grapefruit, limonene is the monoterpene that's found in there, and is in there approximately, there's 97% of that in the grapefruit. Lemon is the same monoterpene, but in addition to the limonene, then you have the theanine, and both of those are found approximately 95% in lemon. Then for frankincense, you have the same monoterpenes that are found in frankincense that are found in lemon, but as you can see, they're not found as much. It's only approximately 75%. And lastly, lime has limonene and then it has terpenine, and those are found in lime essential oil approximately 85%. The next type of terpene that is found in essential oils are sesquiterpenes. And these are some of the benefits of sesquiterpenes: antibacterial, anti-inflammatory, able to pass through the blood-brain barrier, slightly antiseptic, soothing to irritated skin and tissue, calming. And the picture here is a type of sesquiterpene that is found in essential oils. And these are some of the specific sets or sesquiterpenes that are found in essential oils. The essential oils that are on this slide are cedarwood, ginger, myrrh, and ylang ylang. And in the next column are the sesquiterpenes and the amount that they're found in the essential oil. I could go and actually try to pronounce these, but I probably would butcher them. So I'll just leave it up on the screen so that you can see how much they're in, how much these sesquiterpenes are found in the different essential oils that are on this slide. The last terpene that are found in essential oils are diterpenes, and they're found in a low amount in essential oils. And the picture here is a picture of a diterpene that is found in an essential oil. Oxygenated compounds, which if you remember previously, I had mentioned that this is the second component that make up essential oils. And the different types of oxygenated compounds that are found in essential oils are esters, aldehydes, ketones, alcohols, phenols, and oxides. The first oxygenated compound that is found in essential oils are esters. These are some of the benefits of esters: calming, balancing effect on the nervous system, antifungal, and helps muscle spasms. And in this picture, you see an ester that is found in essential methyl salicylate. And as you can see, the reason why it is an oxygenated compound, you have the double bond to the oxygen, and then you have two single bonds and they're bonded to a carbon because these structures are the chemical structures of this compound, but in fact in chemistry this is how they picture chemical structures. And C is for carbon, and there's 3 hydrogens that are bonded to the carbon for the CH3, and then you have an oxygen and a hydrogen bonded together that is attached to this ring-like structure, and this group here is known as a hydroxyl group, the OH. These are examples of essential oils and esters that are found in different essential oils. In this case, lavender, wintergreen, Roman chamomile, and bergamot. And again, in the second column, you have the esters that are found in each essential oil and the amount that ester is found in that essential oil. The second oxygenated compound that is found in essential oils are aldehydes. These are some of the benefits of aldehydes: calming to the emotions, calming to the nervous system, antifungal, antiseptic, anti-inflammatory, and reduces fevers. And what makes this, and this is known as an aldehyde because you have the carbon that is double bonded to an oxygen, and then you have an hydrogen in this picture, which this is an example of an aldehyde that is actually found in an essential oil. And on this slide you have some essential oils: cinnamon, cilantro, lemongrass, and melissa. And in the second column you have the aldehyde that is, or aldehydes that are found in that essential oil, and the amount, the percentage of how much of those aldehydes are found in that essential oil. The third oxygenated compound is ketones. These are some of the benefits of ketones: stimulates cell growth, helps for dry asthma, colds, flu, and dry coughs. And this is an example of a ketone that is found in an essential oil. And there again you see the double bonded oxygen bonded to a carbon, and that's what makes it an oxygenated compound. These are some of the ketones that are found in some essential oils, specifically peppermint, lavender, rosemary, and fennel. And in the second column, you have the ketones that are found in that essential oil and the percentage that they're found in that essential oil. The fourth type of oxygenated compound that is found in essential oils are alcohols. Some of the benefits of alcohols include increasing blood circulation, return cells to normal function and activity, antibacterial, anti-infectious, antiviral, and have an uplifting quality. And this picture shows one of the alcohols that are found in essential oils. And for alcohol, you always find this OH group, which is known as a hydroxyl group. And these are some of the alcohols that are found in essential oils. And specifically the essential oils on this slide are Manuka, also known as tea tree, peppermint, lavender, and basil. And in the second column you have the alcohol that is found in that essential oil and the amount that is found in that essential oil. The fifth type of oxygenated compound found in essential oils are phenols. Some of the benefits of phenols include they stimulate the nervous system and immune systems, antioxidant, antibacterial, and antiseptic. And here is a phenol that is found in essential oils. This specific phenol is actually found in oregano essential oil, but it can also be found in others. And speaking of oregano, you have, these are some of the phenols found in essential oils. In this case, on this slide, it's oregano, clove, and thyme. And then in the second column, you have the phenol, or the phenols that are found in that essential oil and the amount that they're found in that essential oil. The last oxygenated compound that is found in essential oils are oxides. Some of the benefits of oxides include they're anti-inflammatory and they can act as an expectorant. And what an expectorant is basically it allows you to cough up mucus. And this is an example of an oxide in this picture that is found in essential oils. And in this case, you see the oxygen atom, but it's in a ring structure. These are some specific examples of oxides that are found in essential oils. The essential oils that are on this slide include eucalyptus, peppermint, rosemary, and thyme. And as you can see, it's the same oxide that was mentioned on a previous slide, but it's in different amounts depending on the essential oil. Essential oils and the body. This picture is a picture of our skin. The part that looks like tiles is actually the top part of our skin, the part that you can actually see when you touch your skin, and that's known as the epidermis. Then this middle layer is the dermis. And basically, as far as how essential oils work, this is when it is applied topically, which just means it's applied to your skin. You apply it to your epidermis, which is this top towel-like layer, and it depends on how much it is. If it's able to pass through the epidermis and into the dermis and enter one of these blue or red vessels that you see here. These are blood vessels or capillaries. If it's able to enter that, then it will enter our bloodstream and it will actually have more of a whole body effect. Now, if it doesn't enter the blood vessels and it just is able to just stay on the epidermis, then that means that it will just have a local effect. So it will just affect where it was applied. So say if I apply lavender to my arm and it doesn't penetrate into the dermis, which is the middle layer, and enter the bloodstream, then that means that I will just feel the effects on my arm, and I won't feel it won't be a whole body effect. In this picture, this is a picture of our cell membranes. When essential oils pass through, since our cell membranes are made up of a type of fat, and essential oils are another type of fat. Essential oils, because they are small and also because they are a type of fat, it's able to pass through these lollipop-like structures and into the cell. And then that means that it can actually affect the cells. Picture of the limbic system, and a lot of times people wonder, well, how are essentials able to affect my mood and the brain? And this is how. Some essentials can actually cross the blood-brain barrier. Those essentials include frankincense and sandalwood. For the essentials that can't cross the blood-brain barrier, then they interact with the brain through the limbic system. And this is a picture of the limbic system. And what happens is for the essentials that can't cross the blood-brain barrier, when you inhale or diffuse an essential, then the olfactory bulb is activated, and the olfactory bulb is also connected to the rest of the limbic system, and the limbic system processes our emotions, our memory, and our sense of smell. The way, for example, say if when you were a child, you had your grandma, she would bake your favorite cookie, and you're an adult now, say you're an adult now, and you smell those type of cookies that she used to bake, it triggers that memory, and with that a memory there's a certain emotion that is associated with it. And that's actually how essential oils interact with our brains. It's through our sense of smell. This will bring webinar to a close. I hope you found it informative. I want to thank you again for attending webinar 2. And if you have any questions, you can contact me by going to www.mydoterra.com/Marlena Sherman and click on Contact Us. And stay tuned for webinar 3, which will be single essential oils.